Here we have an example. A body of mass 0.5 kilograms is attached to a wall by a spring of constant 100 newtons per meter. It is given an initial velocity, at x equal to 0, of 5 meters per seconds. Letter A, find the total energy of the body. Letter B, find the amplitude of oscillation. Letter C, find the velocity when the displacement is half the amplitude. Letter D, find the displacement when the velocity is half the initial velocity. Letter E, find the displacement when the kinetic and potential energy are the same. Letter F, find the frequency and the period of the motion. Letter G, find the maximum acceleration of the body. Here we see a drawing of the problem. We examine that x equal to 0 would be at its maximum speed. First we find the total energy of the system. Based on the given, we can calculate the total energy as the sum of the kinetic energy plus the elastic potential shown in equation 10.21. At maximum speed we see that x is equal to 0 and we get that the total energy is equal to 6.25 joule, which is constant. For letter B, we find the amplitude of oscillation at the condition where its speed is equal to 0 and the length x is equal to a. We see that it is about 0.35 meters as the maximum amplitude of oscillation. Letter C, we find the velocity of the mass when its displacement is half of the displacement. We do this by using the conservation of energy and setting x equal to half of the amplitude. We rewrite this equation and obtain a value of about negative or positive 4.03 meter per second. Letter D, we find the displacement when the velocity is half the initial velocity. We do this by using the conservation of energy and setting the velocity to half of the initial, and we get that the displacement is about 0.31 meters. For letter E, we find the displacement when the kinetic and potential energy are the same. We set the kinetic energy equal to elastic potential energy. Rewriting the equation we see that the displacement is about 0.35 meters. For letter F, we find the frequency and the period of the motion. So, we recall the frequency equation and the period relation, and it is about 2.25 Hz for the frequency and the period is about 0.44 seconds. We use the ideal equation to solve this problem. Recall the expression for acceleration and we get that acceleration maximum would be at x equals to a, where the velocity is 0. Then maximum acceleration is given as the equation shown here, and substituting the amplitude a we get that the maximum acceleration is around positive or negative 70 meter per second square.